Hi, my name's Cora Colbert, and for my engineering project about renewable energy sources, I'm going to be talking about geothermal energy. So for my project today, the contents are going to be what is geothermal energy, my introduction, materials that are going to be used, the process, data, equations, calculations, and my conclusion, benefits of this source of energy, pros and cons, practical applications, and future expansion. So what is geothermal energy? It is a renewable resource, and it comes from the Earth's core, and it's a significant source of power. Geothermal energy is used for heating and cooling, along with the generation of electricity. It works by wells being drilled into the ground, into underground reservoirs, and it uses the hot water and steam from these reservoirs. Geothermal energy is a clean and renewable source, and it has a small environmental footprint. So for my introduction, I'm going to begin with my problem statement, and that is that with the different types of renewable energies, is geothermal energy a good alternative? And my assumptions that I'm making before this project are that um, about geothermal energy, it is going to be a it is going to be a reliable source and doesn't fluctuate like other energy sources, such as wind, solar, and hydro hydro. Another assumption that I'm going to be making is that geothermal energy will increase in the future. Materials that are used is that at geothermal plants, the main factors used in this process of conversion of energy is hot water from the earth, steam, turbines, generators, cooling towers, and injection wells. So in this process at the power plants, it begins with hot water being pumped from deep underground through a well under high amounts of pressure. When this water reaches the surface, the pressure drops, causing the water to turn into steam. The steam spins a turbine, which is connected to a generator, and this produces the electricity. The steam then cools off in the cooling tower and condenses back into water. The cooled water is then pumped back into the earth so this process can begin again. So in this project, I'm going to be talking about a single flash cycle, and this is a type of process at power plants of a single throttle valve and one separator to generate steam from pressurized liquids. So for my data and equations, I began with using the equation for efficiency to calculate the efficiency of the geothermal energy. And so what this equation is that it is the efficiency percentage, which equals W over MH times 100. And so what this equation means is that W is the running capacity, M is the total mass flow rate, H is the reservoir enthalpy. And so the data that I'm using within this project is that I am using the Killdeer inform information from Killdeer power plant, which is in Turkey, and it's a single flash plant, which means that it's using that single flash cycle. And so from this information that I'm going to be using in the equation is that W is going to be 20.4 megawatts electrical. H is 87,875 kilojoules per kilogram. And M is going to be 1,000 tons per hour. And these are the numbers that I got for my data. And so when doing this calculation, the first thing that I'm going to do is I'm going to be converting these numbers into a form which I can plug into the equation. So for the running capacity, which is W, I'm going to convert this by doing 1 kilowatt energy over 1,000 megawatt energy times the 10 megawatt energy, and this gives me 10,000 kilowatt energy. And this is going to be a number that I can put into the equation. For the 875 kilojoules per kilogram, that is already ready for the equation, so I don't need to do anything for it. And for the M, which is the total mass flow rate, I'm going to convert that by using the conversion of 1 ton, which equals 1,000 kilograms, and 1 hour equals 3,600 seconds. And with using those two, I'm going to do 1,000 kilograms divided by 3,600 seconds, which gives me a 0.277 kilograms per second. And so with this number, I'm going to multiply it by the 1,000 tons per hour, which is going to give me 277 kilograms per second. And that's going to be the user I use. It's going to be the user. It's going to be the number that I use for my equation. And so with calculating the efficiency for geothermal energy, my equation is going to be the efficiency equals 10,000 kilowatts energy divided by 277 kilograms per second times 875 kilojoules per kilogram times 100. And so after plugging those numbers in, I'm going to just solve for the percentage. And on the left, you can see my calculations. And through this, it equals to 41.2%. And so for this Kilsdeer plant, it produces 41.2% efficiency of the heat from the separator to the turbine. So with my conclusion after doing this is that the efficiency of geothermal energy, it does have a small output compared to thermal energy, such as coal. But in the grand scheme, when you're comparing it overall, the geothermal energy is more efficient because it uses less resources. And you can see that by the materials that is put into this process. And so looking back at the problem statement, I do think that it is a good alternative when it comes to renewable energy. It is a sustainable energy because it helps reduce greenhouse emissions. Although there is a certain condition which the geothermal plant can be in regarding location, it's a reliable source of energy in comparison to solar and wind. Geothermal energy has lower environmental impacts on the surrounding environments, and this is the low impacts are examples like leaks from the plant or earthquakes because of the plant. So some pros and cons for the geothermal energy is that, of course, as I stated, the pros are it is more efficient because it uses less resources, so it has a lower efficiency rate compared to thermal energy, and it utilizes a stable underground heat source, which results in reduced energy consumption and a more consistent heating and cooling output. And some cons of it, of course, like how I stated, is that it does have a lower conversion efficiency, depending on the factors of the plant. And so some of the factors that can affect it are things like local climate, soil conditions, and the presence of non-condensable gases. And so with these factors, they may influence the efficiency and production of the usable energy that goes into the geothermal energy. A benefit of geothermal energy is that aside from the benefits that I did state before, it also has a significant lower cost of using this type of energy. So it uh, you're able to save a lot more when using this compared to thermal energies. And so some practical applications of this is that along with large power plant scales, this can be used in small scales. So from using the hot water and steam from reservoirs, it can be directly used. Um, so on smaller scales, on smaller scales, the geothermal energy is directly used from the reservoirs, and this can be used to buildings, agriculture, and industrial plants. And the future expansion of this type of energy is that an analysis was done by the U.S. Department of Energy Geothermal Technologies Office, and it's found that geothermal energy generations can increase greatly by 2050. And to help this advancement, the DOE funds different programs, such as the Wells of Opportunity, which provides up to $14.5 million to the geothermal energy production. And so with doing this, these investments expand the U.S. capabilities for clean energy jobs and provides opportunities for workers in the oil and gas industry to transition from that to the renewable energy industry. And so with all of that, I conclude that overall that I do think it is a good alternative in the renewable energy sources. And here is my citations. And that concludes my presentation. Thank you.